Hello again, folks. It's Barry with Barry's 8-Track and Classic Car Radio Repair. And this video is basically going to describe what I've done during my 2017 September shutdown. Every year, due to the growing popularity of my business, methods that I used originally simply will no longer work for the increased workload as my business grows a little bit each year. At this point, I'd like to thank all the restoration shops all over the country, as well as individuals, for trusting me to send me their work. Massive amounts of money and potentially irreplaceable equipment. It's quite an honor to be the technician for you guys, as well as being the behind the scenes technicians for a lot of classic car restoration shops all over the country. In an effort to continue delivering top quality service, I have finally finished my video camera setup that I'm going to show you right now. If you guys have been watching my videos, you already know about my massive top quality sound system that I use to enable you to hear the shift from left to right, front to rear balance, and all that stuff. Well, I finally have finished my 38 camera video project to supplement that, and so now we're just going to run through all the cameras, and I can show you guys all the various tests I can make to ensure that you're receiving a unit that's been tweaked to perfection as well as possible. So we're just going to go ahead and run through these cameras here. This is camera 1. This is the one that you've seen the most often. This is my little intro and exit camera that I use. It's focused on my face, obviously. And then you've seen my, this is the camera that is usually trained on the customer's finished unit. And right now I've got my video cameras that I've been using. Now, 4 of the cameras that I use are actually former broadcast quality TV cameras, Sony DXC3000s. I use those cameras for positions where, for instance, if I want to zoom in from the bench, but the camera's 15 feet away, then I've got that camera's remote box that I can use to zoom it in and trim my focus and black level and all that kind of cool stuff. So now I'm just going to show you most of the cameras that I use are these little, naturally I can't afford 38 HD brand new cameras, and integrate it with my analog system. So what I do is I use these little security cameras, which work just fine as long as I put decent lenses on them. Now, this is the type of lens that is normally used with these little security cameras, but the lenses that I have to use in order to fulfill my needs are more like this. These are some serious cameras or lenses with a lot of weight, and I've actually had to go through 3 different types of mounting brackets for these cameras to find brackets that are tight enough that the camera does not sag over time. So that's just a little deal there to share with you guys. This is a pretty decent quality zoom lens, and these actually weigh a few pounds, and the most video camera mounts simply are not designed to support that kind of weight. So I had to go through 3 different types of mounting brackets for these cameras just to find the ones that are not going to allow the camera to sag with time. So that being stated, and this of course is our unit under test camera angle, the one that you've seen quite a bit, I'm sure, with my other videos. And now we'll move back to my face, and we'll go to camera 2, which is my output level meters, and you've seen this one quite a bit as well. And this is the one where I can actually add the shot of me operating the customer's unit in the inset in order to so the customer can see me adjusting the controls as they observe the results of that. So that's camera 2. Camera 3 is, this is my HP 8903A audio analyzer. This measures actual power output, it measures distortion levels, it measures a signal to noise ratio, it measures SINAD, and quite a few other parameters that I don't really have time to go into right now. It'll do sweeps, audio sweeps, from across the entire spectrum when I want to do sweep tests and sweep analyzation and things like that. It also has a built-in frequency counter, so I can ensure absolute accuracy on a lot of different parameters. So that's my my little HP 8903 audio analyzer, which has a lot of cool features. And now we'll move on to camera 4. Camera 4 is my wow and flutter meter, and my wow and flutter meter also has a frequency counter built into it. There's a lot of frequency counters at my bench, and one thing I like to do is I like to have at least two of every type of equipment that I would need. Just in case I suspect that a piece of equipment might not give me accurate readings, then I can always switch in another piece of equipment that does the same thing and make sure that those readings agree. So this is our frequency readout, and of course this is our wow and flutter reading that I can show the customer to ensure that his tape is running at the precise speed and not speeding up and slowing down. And as you can see, I have numbered all my test equipment so that all I have to do is just take a quick glance, and this shows me that this piece of equipment is on camera 4, so I don't have to look up through list or try to remember all of it. I just take a look and, okay, I want to measure my wow and flutter, so that's going to be camera 4. So let's move on to camera 5. Camera 5 is basically just an overall view of the bench, and just kind of shows a complete picture of the mad scientist laboratory and all the equipment that I use. Once in a great while, I have to utilize this camera angle for. Can't really think of a reason at the moment, but it's nice to know that it's there. So now we're going to move on to camera 6, and camera 6 is my basically this is just your basic volt ohm meter, bench multimeter. And this is what I use every single day just about to measure voltage, continuity, current, resistance, and things like that. Most people know what that meter does, so there's no real need to go into a lot of detail on that one. But I did build this thing into a neat little deal. Since this is at the bottom of the stack, being the most used piece of equipment, it's at the bottom of a big long stack of test equipment. We'll go back to the overall view. My multimeter is right here at the bottom of that big old stack of stuff, and I have made this thing so that if this meter ever fails, all I have to do is slide it out, and I've got 4 more meters that I can just take the next one, slide it right back in, and I can replace this meter within a matter of about 30 seconds. So that's kind of a handy deal there. And then into the left side of this cabinet, I've built basically level controls for my 4-channel stereo receiver that I use for quad decks. I've also built a tape head preamp into it in case I need to test a head. I don't need to whip out a preamp. I got a preamp right there, and so on and so forth. So we'll go back to what I was doing. That's the meter itself. And now we're going to move to camera number 7. 7, that's just basically trained on my bench test receiver, so that I can show the customer, another aspect of which test I'm performing, whether or not it's in surround mode. Obviously, it says surround off, so it's not in surround mode. And that'll become important in the next few minutes here when I demonstrate a couple other things. Okay, so let's move on to camera 8. Camera 8 this is one of my LCR meters. This measures inductance, capacitance, ESR, which is equivalent series resistance. That's if you want to measure a capacitor without taking the capacitor out of the circuit. And in most cases, the surrounding circuitry won't throw off the capacitance reading. And just a quick demonstration, I've got it set to a reading capacitance mode at the moment. We're reading about 20 PF, and all that is that's just measuring the capacitance of the wires that run between this instrument and my master switch box that I'll be showing you later. And if I just bring the switch box into the circuit, you can see how it changes the capacitance. Now we're at about 33 or 34 PF, and we'll switch this box back out, and we go back to just measuring the capacitance of the leads. 20 PF is a pretty negligible capacitance, and I just subtract that off of my total reading when accuracy dictates that I do so. So that's camera number 8. Let's move on to camera number 9, and this is just your basic audio generator. I can dial in any frequency within the human hearing range at different voltage levels. Let's say, for instance, I want to measure 440 hertz, which is A on the piano, and so we can just there's 440 hertz at say 200 millivolts to test how the line input's doing, and now I've got 440 hertz at 200 millivolts, and it's self-correcting several times every second. It'll do sine wave, triangle wave, square wave, ramp, and also pulses. And this one's a little bit more hardy than the other audio generator I'll be showing soon. This one will go up to about 10 volts, whereas that normally goes up to about 3 volts. So, got that figured out. Let's move on to camera 10. Camera 10 is one of my RF generators. This is a Fluke 6060, a very popular RF generator. It'll generate both AM and FM carrier frequencies that I can modulate to actually feed a signal into the radio and make sure that my selectivity is good. Right now I've got it set to the end of the FM band, 108 megahertz. If I want to go to the beginning of the band, it's a simple matter just to go to 88 megahertz and say I want to kick this level down to about 4 microvolts to test FM sensitivity. And now we're at 88 megahertz at 4 microvolts. Much quicker than the old-fashioned dial things where you have to kind of measure, as you put it out to make sure that it's accurate. This has all the measurement built right into it, and everything's cool. All right, now we'll move on to a camera 11, which I believe is my master connection box. It's a patch bay. This is right in front of me, and what this thing does, this is just a patch panel that I've got all this test equipment connected to this box. And so instead, like say for instance, I want to connect my audio generator to, say, the frequency counter, I don't have to run a cable, all the way across from one piece of equipment to another. I just do it right here, and for instance, I can measure my, if I've got my audio generator right there, I just connect that, and then I can connect that with any other piece of equipment. And in addition, I can also plug a scope probe into either one of these, and then I just use my switch here to run. You can't really see it very well, but we've got different colored LEDs that move across and that way I can just take a scope probe and connect it to any piece of equipment without having to reach way up and have wires, tangled all over the place in front of all my gear. This takes care of all my switching needs from one piece of test equipment to another. I can, for instance, plug a probe into a generator and then plug another probe into like a signal tracing device, and that way I can just do all my switching from right there. Now these little digital things below, these are all timers. This timer on the left controls my left stack of equipment. This timer in the middle controls all the rest of my equipment. As I've mentioned in other videos, it's not good for any electronic device to sit around for a long time without being used. That's when it tends to malfunction when you first turn it back on again. And if you think about it, how often have you been watching a TV or listening to the radio and it just quits right then all of a sudden? It hardly ever happens. Normally it's after the piece of equipment has been left off for a long time, and then you go to turn it on, and that's when it stops working. What I do is to keep my equipment healthy, because some of this equipment I only use once in a while. To keep my equipment healthy, I've got it all on these timers. Number one, these timers will only allow the equipment to stay on for half an hour or as long as I choose to set it. And then also when I get up in the morning and I turn on my bench, it turns everything on for a half an hour. That way, whether I'm using it or not, it's on for a half an hour every day to keep it healthy. And then the timer on the right here, these go to my soldering irons. I use at least 4 different types of irons in my work. I've got desoldering irons. I've got like a little 40-watt iron for general use. Then I got a big old 80-watter that I use for tougher jobs like soldering wires to a steel chassis. And so these timers ensure that my test equipment and my irons are all turned off. If I should forget to turn them off, like if I'm on my way to the grocery store, half the time I have to come back and make sure I didn't leave an iron plugged in so that the cats don't knock it over and start a fire. So I've got everything on timers, and I'm going to go ahead and reset all my gear so that it doesn't turn off. It would normally turn off in the next 15 minutes, so I just went ahead and reset it so it stays on. And so that takes care of my my master patch panel and my box. And so now we can move on to other cool things. Camera 12 is another audio generator, looks like. This is the same model as the previous audio generator I showed you. This is the HP 3325A. And once again, we can go 500 hertz at, if we want to say 100 millivolts for testing a line input, we've got it right there. It's precise and accurate. I don't have to worry about it. So now we're going to move on to a piece of equipment you will not find in any other shop. That is an FM stereo generator. It's not necessary in order to troubleshoot FM stereo radios. It's really not necessary to have a stereo generator because there's other means of testing the multiplex functions. But I, being obsessive about having all the right gear, I did go to the expense of buying one of these. You normally can't find these for less than about $600-700, and that is used. And you can normally only find them overseas. For some reason, Singapore has quite a few of them. But at any rate, I did go ahead and purchase an FM stereo generator, and it also does AM, FM stereo generator. You can modulate it with either AM or FM signals. You've got your FM pre-emphasis that you can switch into the circuit. You've got your pilot signal. You've got your actual stereo output. And if, once again, if I want to go to 88 megahertz to test the low end of the band, and you just want to put it, say, at let's try five microvolts. Now we're putting out 88 megahertz at 5 microvolts to test FM sensitivity, dial accuracy, things like that. And so that's my Panasonic 8131 FM stereo generator that you're not going to find at many shops because they're not really all that necessary. But I just like to have all that cool stuff just to make double sure that I'm putting out the top quality work as top quality as possible. Now we're going to move on to camera number 14, whatever that's going to be. And what I've got camera 14 focused on at the moment is my little desk TV or my little TV that I watch on the bench for entertainment. And I've also got it loaded with some software that allows me to take frequency response plots. And what we're looking at right now is kind of a not very good frequency response plot for just the output of a white noise generator. And as you can see, the scanning rate of my TV doesn't agree too well with the scanning rate of my cameras, so we're getting a little bit of flicker there. But at any rate, I've got basically your spectral analysis that I can measure the entire audio spectrum of any noise, sound, or piece of music that I may have to run into. Right now it's set to just to read some white noise. Okay, so we'll move away from that. We're going to go to my overhead camera. This is the camera that I've got above the bench, and it just gives me an extreme close-up of whatever I'm working on. Like if I want to show the customer, how to make an adjustment, or other things that require this close of a view, then I can just switch to my overhead cam. Okay, then we're going to go to number 16, and this is a left side bench camera view. Of the same thing, but from the left side and slightly above, zoomed in nicely. If I want to turn the unit on its side, show the customer a problem that he's having with a belt slipping or something like that, I can do that. That's just your basic extreme left view of the bench. Okay, now we're going to move on to camera 17, and what this is just one of the banks of cameras I've got mounted. This, I believe, is 18 of those cameras, and you can see I've got 4 shelves full of video cameras there, and plus a few cameras mounted on the side. I believe that's a total of 18 cameras. Those are all cameras that are trained on the pieces of test equipment that I've been showing you. That's what all those pictures are coming from, is those cameras up there. Okay, now we're going to move on to this is my certification as a technician. I've been, as you can see, I've been a certified technician since 1996. You'll see that date right about there. I do have it's got my social security number as my ID number, so I've got that covered. A little other personal information I've got covered up, but that is my certification as a technician that I've had since 1996. Okay, we'll move on to camera 19, whatever that's going to be. Camera 19 is an analog meter. Digital is not always the best stuff to use, especially if you're testing a control like a pot potentiometer. You want to make sure that there's no dead spots in that control. And using a digital meter, that's not real easy to see, because whether or not the control's bad or good, you're still going to see changing numbers, the same thing. Whereas if you're using an analog type meter, it's a lot easier to see where there's a dead spot, because that needle will suddenly move. It won't move really smoothly like it is now. You'll see that needle suddenly move. So whenever I'm testing a control, I like to use an analog meter instead. And then above that, I've got a digital meter as well, which I don't really use much anymore because I got that other one that's right in front of me. But so over here I've got both analog and digital standard multimeters. So we'll move on to, this is just another view of my face. You guys are probably tired of seeing me head on, so now I've got this other angle that I can talk from. Hi guys, it's still me, just at a different angle. And that's all that camera is. And so move on to camera 21. Camera 21 is a Gauss meter. This is what I use to measure the magnetization level of a tape head before and after I demagnetize it. This is a very sensitive meter. It will actually measure the Earth's magnetic field, which is 1/2 of 1 Gauss. And this meter will measure down to a tenth of a Gauss full scale, and that's 1/10 of 1 Gauss, and it'll measure up to 30,000 Gauss full scale. Pretty interesting meter. Another thing that you're not going to find at most other repair shops, simply because they're not really all that necessary. They do kind of cost more. The probes alone for this types of meter cost about $250, and that's used. So this is something you won't find at many shops because they're really not all that terribly necessary. I, being the mad scientist, still like to have them on hand to use, just to ensure that I'm putting out the highest quality work that I possibly can. So we're going to move on to camera 22. Camera 22 is another LCR meter. This one is a little bit of a cheaper model than the one that I showed you on camera 8, and this is the one that I use more often, simply because if I'm going to put a lot of wear on something, I want it to be something cheaper. I really like my HP gear, and so I kind of baby it at times, but it's always nice to have at least two LCR meters, so that you can confirm one reading against another and make sure that it is accurate. So that's just another one of my LCR meters, measures capacitors and inductors. And so we'll move on to, let's see, that's camera 22. All right, let's go to camera 23, and this is just another view of the bench from the right side this time. If I want to tilt the customer's unit the other way so I can show them something on the other side, then I've got that camera angle covered right here as well. So we're going to move on to 24. Camera 24 is basically a DC voltmeter. This is when I want to show the customer that his converted radio will work just fine down to, say, as little as 9 or 10 volts. Then that's what that meter's for there. That'll come in handy at times. And that's 24. Let's go to camera 25. Camera 25 is basically, this can be used as a regular oscilloscope, but it is also a real-time analyzer. This gives me a frequency readout across the entire audio spectrum with the levels of the waves being visible. And I'm sorry I don't have it powered up at the moment. I kind of forgot to turn it on. But this is a real-time analyzer that measures the entire frequency response of any type of audio device, as well as being just a regular oscilloscope, which is what I normally use it for. But it's also nice that I have that ability to measure the audio spectrum and a unit's response across the audio spectrum. Let's go to camera 26. Camera 26 is a phase meter. And this is when I want to ensure that the output of an amplifier is in phase with the input. If you're an audio enthusiast, you've heard the phrases in phase and out of phase. You know that if you've got two speakers connected out of phase with each other, it creates kind of a hole in the sound. You lack a little bit of bass response. So this is just, it's not always a good idea to trust one's ears, no matter how well trained they are. It's always nice to have equipment that will actually measure this stuff. So this is basically a phase meter. This is another thing you won't find in probably any other audio shop of this kind. Once again, it's not really all that necessary. It's just one of those obsessive mad scientist things of mine that I like to have all the right gear in case I ever need it, and I do sometimes use it. Right now it's not measuring actual phase. There's nothing connected to it, but it's there when I do need it. So that was number 26. Let's go to camera 27. 27 is my frequency counter. This is a dedicated frequency counter, and you've seen that I've got other counters. My HP audio analyzer that was on camera 3 will also count frequency. The Wow and Flutter meter on camera 4 also has a built-in frequency counter, but this is an actual dedicated frequency counter that'll measure down to just ridiculous levels of accuracy. So it's always nice to have a dedicated frequency counter, and this one will also measure phase just like the phase meter did. And so then again, I've got redundant systems to measure pretty much any parameter I would ever need to measure, simply by firing up another piece of test equipment that will perform the same function and make sure that its reading compares favorably with the previous piece of test equipment. So it's just more overkill on the accuracy of service I can provide. Let's go on to camera 28. We're getting close to the end here, so be patient. Camera 28. This is just a basic oscilloscope, but this one measures up to 350 megahertz, whereas the other scopes I've got are primarily audio scopes, measure usually up to 50 megahertz or less. This scope will go up to 350 megahertz. Like if I want to directly read the carrier frequency of an FM signal, which maximum frequency would be 108 megahertz, this scope goes all the way up to 350 megahertz. It's not very often used, but once in a while it is, and when I do need it, I really need it. So that's why I've got it. Okay, camera 29 is Okay, camera 29 is our 4-channel audio spectrum analysis setup that I've got. I am definitely the world's only shop of my kind who has one of these, and this is basically gives me a spectral analysis of, of course, you've got left front, left rear, and right mirror. At the moment, I only have the left front and right front into the system, so let's just measure real quick.
I got a ton of pride in was
measure what's going on in the radio.
Screaming out hours after.
I mean, as you can see, we're getting mostly low frequencies because the speaker, it's a male speaker speaking, so we're getting mostly
so many of them,
low frequency response.
It came out that they're military vets and off-duty law enforcement, and I just took a ton of pride in that.
These are actually just LCD oscilloscopes with the FFT function. That's a fast Fourier transformation, and that gives us a true real-time spectral readout of whatever kind of signal you're putting into it, and that comes in especially handy for making head azimuth adjustments, which involve a high frequency of about 8K, which is just within the range of most human hearing on the high end, and the ear can get fatigued after very quickly can the ear get fatigued when listening to those frequencies. So that's why it's nice to have actual readouts where you can see it with your eyes and match it against a grid so that you know that you're adjusting using your eyes in a definite pattern as opposed to relying on your ears, which may be really fatigued after just a few seconds of trying to make that adjustment. So you've seen the spectral analysis. If you've been watching my videos, you've already seen me adjust the head azimuth using the spectral analysis. So now I finally have a dedicated camera trained on this group of 4 scopes to provide that spectral analysis, and it's no longer a fisheye lens, so it's not looking all weird and distorted because this camera focused on this is now about 15 feet away. So we've just made a little bit of improvement on the coverage of our 4-channel spectral analysis. Okay, that was camera 29. So from here on in, I think we're going to be looking at pretty much blanks. This is my shipping area, and I'm waiting on a mounting bracket for that camera. I came up 1 bracket short, so I can't. I don't have this camera operating just yet. But this is going to be overlooking my shipping area, where I'm going to be showing customers how to pack different types of units for safe transit. I do get a lot of units that arrive a bit damaged, and so I'll be putting out some videos on how to pack certain types of units, and that'll be coming predominantly from this camera. This camera number 31, that one is also not hooked up, but that's why it's just gray right now. That's one of my Sony professional TV cameras that I can use for pretty much whatever I want to use it for, and at this point I have not yet decided exactly what I want to use camera 31 for, so therefore I don't have a camera hooked in yet. And then camera 32 is another one of my Sony cameras, which is currently trained on just a little piece of gear just for fun. It is not going to be its permanent position, but that's one of my Sony professional TV cams. And one thing about those professional TV cams is that I can vary a lot of settings. I can open and close the iris from the bench. I can change the black level, the white balance and stuff like that, like I'm doing now. I can vary the amount of signal that goes into it, give it more contrast, and I'm doing all this from the bench using the camera's remote box and not having to touch the cameras. So that takes care of, that covers 33 of the cameras, because that's 32 cameras plus our view of the unit under test, which is on a completely different channel, so that's 33 of the cameras. There are 4 more cameras in my system that don't feed directly into the system. They are just, they go to a monitor that's on my bench, excuse me, where I can keep an eye on the inside of my warehouse to see when a package has been delivered, and I also have a camera both on my front and back porches just in case UPS decides to put them on my porch instead of in the warehouse. I can see that as well. So I've got my front porch, my back porch, the inside of my warehouse, and also it looks out over my driveway. So I can look from working on the bench. I just look over and I can see when the mail's coming, when UPS and FedEx are coming. I can actually see how they put their packages in the garage. If they just open the door and throw them in there, then I've got them on tape and say, hey man, you damaged this customer's unit, and I've got the tape that shows how you threw it in there. So just everything I do, it's all about delivering top-level service and long-term reliability. And so you can probably see by now the pains that I've gone to in order to bring all those things about. My shop is based on website traffic. My shop is the world's most popular service among all shops specializing in the repair, restoration, and conversion of classic car radios and 8-track players. It has been 10 years of old 18-hour days at least. In many cases, I stay up 2 or 3 nights even, simply because I love my job and I've got deadlines to meet. And so I want to once again thank all of you guys, all of you individual customers, and all of you restoration shops all over the country who have trusted me with your units and have had a chance to see, the quality of my workmanship, the video proof I offer of that, the way that I stand behind my warranty. I've gotten a lot of really gratifying emails from all you guys, and I really appreciate your business, and it makes me secure with the fact that my hard work is paying off and that it's being appreciated. So thank you very much again. This is Barry with Barry's 8-track and classic car radio repair. Needless to say, if you have a unit either for repair or a service or conversion that you would like to send me, as long as it's within the list of the capabilities that I claim, meaning that it's a classic car radio manufactured roughly between 1950 and 1980, and of course anything with an 8-track player, I work on those as well. For those reasons, you can reach me directly at 928-533-9666. My website is in the description below. Thank you very much for watching, listening, and we'll see you next time.